Good morning. My name is Randall Barney. I'm actually Executive Director for the World Teleport Association. And welcome to our roundtable discussion, Ground Game 2.0, Strategies for Teleport, Earth Station, and Data Center Services in a digitally driven and multi-orbit era. The satellite ground segment is undergoing one of the most significant transformations in its history. No longer is it enough to simply add more dishes or expand capacity. The shift toward multi-orbit constellations, multi-band operations, and cloud integration services is forcing teleport, earth stations, and data centers to reinvent themselves as agile, software-defined service platforms. Today, we'll explore how modernization, automation, and digital convergence are enabling ground facilities to move beyond traditional RF boundaries, positioning them as vital hubs for the space industry's next chapter. I'm joined by 4 leaders bringing perspectives from commercial operations, systems innovation, and terrestrial telecom. And I'm going to briefly ask them to introduce themselves and their company. We'll start with Francesco.
So good morning, everybody. My name is Francesco Cataldo. I've been in the industry, a lot of people know me, since 41 years. I started when I was very young, working as a subcontractor for space agency. And then I moved to Eutelsat, and I've done all my career in the sales. The last 2 years, I've been going back to operations. Today, I'm working with ICO Media Group. I'm the chairman of this group. We are mainly focused on media distribution. We have 3 teleports. So we understand teleports, we understand what the complexities of managing teleports are, and this is probably why I'm here.
And Miguel?
Hi, good morning. I'm Miguel Peña. I'm the sales director of Celestia Group. Celestia is a group of companies around Europe providing solutions for ground stations, subsystems, and in some cases, end-to-end solutions. And we will be happy to share today what are the technical challenges that we are facing and how we think we can help the industry in the new challenges that we have ahead of us.
Okay, Andrew?
Hi, my name is Andrew Bond. I've been with ETL Systems, who are a ground equipment manufacturer. I've been with them for 21 years. Obviously, the amount of time that people are in this industry, it's a very infectious industry, so we are often here for a long time. I'd just like to say we have started really with 6 or 7 people. Thanks very much to BT Madley, and it was really good to see that slide a few minutes ago. And that's really grown from when we first started supplying equipment to BT Madley to now having an installed base of about $300 million of RF ground analog equipment and fiber equipment around the world. So it's really indicative of the growth in satellite and the success of satellite that ETL Systems has been part of this journey.
Okay. Andy, do you want to remind them?
Yep, Andy Sutton. I think you've heard enough from me for now, so I'll let you questions. Thank you.
All right, great. The satellite ecosystem is now multi-orbit and multi-band. How is this shift redefining the role of teleports, earth stations, and data centers? Francesco?
Well, I think that we as teleport operators are not afraid of operating multi-orbit and multi-frequencies. I think that the major challenge that we have is making sure that at a regulatory level we are protected, because chaos doesn't help. You know, we see here questions related to sovereignty, and then we've seen questions of privates coming along. So this is the first issue. Second, I think it's very important to consider what are going to be the costs for operating in these new frequencies, because we've been used to an industry where we've been using Ku band, C band. We moved to Ka, which required a lot of developments, testing, and now we're thinking of moving to these high-level frequencies and moving from RF to optical. And this requires, I would say, a big effort from the whole industry to make sure that, 1, we get the quality of service which is required, 2, that the costs of the terminal are affordable. If not, the whole project will collapse. I mean, if we have to do something, it has to be done in such a way that everybody in the value chain benefits from such a new innovation. So I think that teleport was the easiest part of the whole business line. It's more related to what are we going to be delivering at the end.
Thank you. Andy, how is this redefining BT's role as a teleport operator?
Yeah, that's a really, really good question, and it's a massive topic to explore. But I think if one thing's critical is that we absolutely have to introduce new frequency bands. We need more spectrum, we need more capacity. We've really gone to great lengths to exploit what we've had access to so far. From a BT perspective, we see Satcom changing from being that standalone solution that we land into Madley and then connect into our network to being a part of a network of networks. And BT will be partnering with people. We won't be building all of this ourselves, but we're looking to understand how we use that high capacity underlying terrestrial infrastructure to connect data centers and ground gateways together on a national and international basis, such that we can exploit the optimal conditions for a given frequency in a given geographical area. And I think when we think about satellite and the likes of Q-band, B-band, even E-band potentially, which is temporarily being used on some ground sites in the UK now, and also optical, then we need to think about it in the context of satellite is a network within a network of networks. I think the industry's got to reinvent itself to be able to deliver optimal solutions.
Thank you. And from a technology provider perspective, Miguel?
Well, multi-orbit, multi-technology sounds really nice, but it's really a technical challenge to put everything together. From a hardware supplier company point of view, having universal solutions that could fit on every case, it is very difficult. We at Celestia, for example, are targeting the multi-orbit approach with new concepts for ground stations. We are really focusing most of our efforts in phase array gateway antennas that could give us the possibility to approach multi-orbit configurations with a single ground station, and on top of that, being electronic, we can produce electronic beams to track multiple satellites, and reducing the CapEx and OpEx operations, because what we are trying to replace is a farm of motorized parabolic antennas by a single electronic antenna. Multi-frequency is a different topic because I don't see in the near term the possibility to have systems that could cover all the spectrum. So, of course, we are evolving in the past from KU to KA. KA is now a reality. We are talking about QV, E-bands, that will require to install new hardware in the ground stations. And in the opening session, Ulpia mentioned that one of the objectives is to drive costs down in order to make the space more affordable for everyone. So this is a bit in competence with the costs that we are having now for the new frequency bands. I mean, it's not really a volume market yet, so systems are quite expensive. So we need to see how to make the trade-off to have new frequency bands that are giving us, of course, more bandwidth, but on the cost part, that is also something not easy to manage.
Thank you. And finally, Andrew.
I think that's quite a nice segue into what our engineers at ETL are currently working on at the moment. And Q and V band is certainly one of our major focus areas. And as we're here to talk about strategies for the future, we are looking at Q and V band development, certainly in our frequency converter ranges, And also in our uplink amplifiers as well. We've just acquired 2 companies, both on the SSPA side and also the high-powered amplifier side, both of which now have Q and V-band products. So that is a really good development into higher frequencies, but it enables us to satisfy a growing market. And as the technologies and drivers from the satellites that are launched today and the spectrum requirements, it means that we can satisfy the frequencies of the future. But it does mean, from a manufacturer point of view, we need to be well engaged with partners in this room to make sure that we are as ahead of the game as possible. And that's one of the drivers that we've got with not only our end customers, but also with you guys, the system integrators and the integrators in the room, to make sure that we're talking to you and it's not a surprise. So keep the dialogue open. I know we've got a question about partnerships later.
Thank you. Staying with Q and V-band, Andy, what infrastructure upgrades are most urgent for the ground segment, and how do new opportunities from Q and V-band change the way teleports need to be designed?
If we're looking to maximize availability from Q and V-band, we're clearly looking to have multiple distributed antenna systems on the ground. Now, we primarily operate out of a single teleport today. We do have other capability down at Goon Hilly as well. So from a BT perspective, we're looking at do we potentially partner with a third party and host one of those antenna systems or multiple antenna systems within our facilities? Additionally, really expanding on that point, we've got a lot of large traditional point-to-point microwave radio sites. And again, a large physical estate there that could be used to host capability as we see less and less point-to-point microwave radio in the network moving forward. So again, from a hosting perspective, there's a capability there. But undoubtedly, if you're going to deliver high availability, you're going to need multiple landing points, and you're going to need the underlying terrestrial infrastructure to pull that together. Alternatively, depending upon the type of capacity you're delivering, type of capability, you may have lots of single points with the ability to switch between them. And again, based upon live data and processing of what that channel looks like between the gateway, satellite gateway at any one instance. And again, we have that visibility now, and we have the ability to process that in our data centers. So, yeah, I think there's some really exciting opportunities. I don't think it's a question of if we do these bands, though. I don't think we can afford not to do them. If the traditional SATCOM sector does not do this, there are other people out there investing already.
Okay. Francesco?
Well, I was thinking about the question of costs. And we're talking about satellite, megabit cost, megahertz cost, whatever you want to do. And I've seen in my past experience that we brought in the VHTS satellites and nobody was buying this. So I would like to ask to our friends in this room, if we bring in terabytes of capacity, is there enough demand? At the end, if you bring terabytes, you're going to flood the market, price is going to go down, and the whole ecosystem will collapse. Now, going back to the teleports, these teleports are becoming more complex. They're requiring high level of investments in order to enable SLA quality or for security reasons. I've personally experienced content replacement on a satellite, which was something unique in my career. And we had to invest to understand and to avoid this again. So if we go on the teleport side, yes, we can put the antennas. There's an advantage with optical antennas because they're so narrow that the risk of interference is very low. But what is going to be the cost for these investments? And also, we have to consider that if we're moving from geo satellites, which still have a role to play, thank you very much for that, Andy, to the LEO constellations. LEO constellations do not sell megahertz. They sell megabits, gigabits, and services. Yeah. And the integration with the 5G terrestrial network is something which is being tested right now and seems to be working. What is going to be the future of these experiments? I don't know. But the teleport will have a role to play to make sure that all the information going to the end user is, let's say, secured, is safe, no cyber attacks. And on top of that, for me, again, the cost. If the mathematics financial model is too expensive, people will start looking for different solutions.
Okay. Did you have something, Andrew?
Really only on the importance of antenna design, and we're very aware of the amount of work that has gone on, some successfully, some not so successfully, with the new evolution of antennas. And we work closely with those providers who are being funded and seeing what direction they're making. So whether we go to a new type of connection to LEO as with the technology you've just mentioned, or we carry on with flat panel antennas and the development of quality antennas to handle Q and V band, we have got to make sure that the IF frequency at the ground is also able to handle and modulate that frequency as it comes to ground. So our engineers have to make sure that the IF frequency now starts stretching up to 3 gigahertz, and all the parameters that go with it, from flatness to return loss, once it's distributed around into our phones as TV signals and data signals, is as good a quality at those high frequencies as at standard L band and standard KU that we've been used to.
Thank you. Coming back to you, Francesco, how are broadcasters and media providers evolving ground operations to maintain low latency and reliable delivery in multi-orbit, multi-band environment?
So in terms of latency, if we're talking about satellite latency, geo satellites, it's fixed. LEO satellite is fixed, so we know that there's a big difference. Unfortunately, today, despite all the testing which is ongoing, and I would like to have an exchange with Andy, I'd like to understand if we've managed to solve this issue of handover between satellites, which is causing for broadcast small interruptions of a few seconds, and sometimes it's visible. So this is an issue. I think that for what concerns all operations in the teleport, well, the fact that we are going into cloud ingestion, so content is available everywhere, so the content delivery to the RF is much faster, so we're gaining on that. For what concerns the customer needs, the customer is requiring more and more access directly to the operation so that they can modify at the last minute whatever is required. So this is making us gain time. So at ICO, we are investing a lot in systems where they're fully automated, with security, of course, so that we avoid all potential risks related to content replacement again. And looking at the future, if these tests with LEO satellites are successful, they will never, in my opinion, be able to replace a nice direct-to-home satellite if satellite is still a valid option for broadcasting content. Satellites, in all my years of experience, are the ones which are used to serve areas where local infrastructure is not present. And we see today new developments where we're going from direct-to-home DBS into direct-to-home using IP standards. And I think that this is going to facilitate this world of transition. For example, we are bringing on our satellites, everybody knows fast channels, but fast channels on internet, fast channels on the ground terrestrial networks. But we are starting to do fast channels on the satellite. So it's a bit different concept in terms of operational costs, but we are bringing these channels in areas where nobody can watch them through terrestrial means. So this is a big transformation.
All right, coming back to optical, Andy, do optical ground gateways change the equation for service delivery?
Absolutely, yeah. I mean, just the sheer amount of capacity you can deliver becomes a game changing, but it also means potentially you can then look at actually moving the RF component from that segment purely onto the feeder segment. So again, you get a massive capacity uplift across the system. So yeah, the potential is significant. And yeah, I think it's really been driven, this plus a wider frequency band piece, by a number of factors. Firstly, of course, in many markets, we have connectivity and we have capacity, but actually the drive for resilience in our digital lives is now increasingly critical. I used that example before in my talk, but irrespective of application, we need to be connected. Yeah, and not just us, but other things need to be connected as well. I'd say maritime and aviation are just massive sectors that are going to grow. So optical gateways are a way to actually then optimize in the use of that RF spectrum and increasing overall system capacity. We're already seeing the benefits of inter-satellite links in terms of how we optimize LEO constellations. Multi-orbital inter-satellite links open up even more opportunities. But fundamentally, if we look at optical to satellite and then optical from satellite to ground as well, as let's say a transatlantic cable augmentation, I think augmentation is important here, we're not replacing terrestrial infrastructure, then actually you start to remove a lot of the big concerns now around geopolitics in the world and submarine cable breaks. Yes, you won't replicate the entire system capacity, but you will keep critical systems working. And you may keep communications open to such an extent that we stop the next war. There's some really critical factors that we need to think about here in terms of how we deliver these systems. Yep. And optical is definitely a part of it.
Thank you. Switching to digital transformation, Andrew, do standardization, how does standardization play a role in accelerating adoption of next generation spectrum bands and digital transformation across the ground segment?
Okay. I think the question really here is really around the open platform, which is Diffie, and I'd just like to, I don't know if Kratos is in the room, but just like to applaud their sharing their work and experience in digitization of the RF ground segment. But Diffie has been really open in the way that our fiber has been open, and the way that you can have interoperability between equipment, and that is the vision of digitization on the ground segment. Basically, for those who haven't come across it, we are looking now at delivering a ground segment technology which is digitizing the RF spectrum, initially in narrow bandwidth chunks, 50 to 100 meg, but up to 500 meg, both bidirectional. But really what that means in the digital platform is that there is a huge amount of savings and security. It means that you can have one set of modems, of encoders and decoders behind the wire, and it means that your antennas now can be remote and also redundant, because effectively antenna feed is digitized and it gets fed into a cloud, and it means that if that antenna is removed, you can immediately switch to a standby antenna. So there's a cost saving. There are some pros and cons with this. It does require, certainly for some of the bandwidths, a huge amount of data rates, so you need some quite big Ethernet pipes to handle the RF stream. But we're getting there. I think there's been a plug fest recently, not only in the UK at Catapult recently, but also another one in Germany at Work Microwave, and the interoperability of the equipment that is now being offered by the digital providers is really quite impressive. What needs to happen now, if it's going to be taken on, is the price needs to come down so that it's as attractive as the RF analog infrastructure.
Thank you. Back to you, Andy. As telecom and satellite converge, what does a truly integrated terrestrial and non-terrestrial network look like? Or what lessons from 5G and cloud-native design should the satellite sector apply?
Wow, that's massive. That's a huge question. I mean, firstly, 3GPP is clearly a body that's going to help us to pull this whole story together. So if we just talk about this from the mobile perspective, there's broader issues around terrestrial, non-terrestrial integration that we've touched on already, around fixed as well. But from a mobile perspective, we're never going to replicate the performance of a terrestrial mobile network in terms of frequency reuse, in terms of capacity, in terms of performance. And quite often, we forget about the uplink when we talk about NTN networks. We see lots of data presented that we can deliver 50 megs to a mobile phone, or 50 megabits per second to a mobile phone is perfectly adequate. That's great. But actually, what about the uplink, that return channel? Because typically, we're sending probably about 10% of the data we get down, back up on mobile networks now. That's the kind of ratio we see downlink to uplink typically. So that means we're sending 5 meg back up. Actually, if you look at the 3GPP specs for NTN on the uplink, in 30 megahertz of spectrum, they're talking about an achievable data rate across the cell of 2 megabits per second. So the uplink becomes a problem. So again, we need to understand within that integration, what are the use cases and what are the geographical areas where we need to use them. And then we need to start thinking about mobility. We spent years and years getting schedulers and mobility management to work in terrestrial networks. So if we now start to move from a terrestrial network to a non-terrestrial network and back, we could be generating lots of signaling, lots of drop calls, lots of issues. So we need to think about the hysteresis and how we manage those parameters and have some very, very clean boundaries, but also the cost to serve on a non-terrestrial network will be significantly higher than a terrestrial. So therefore, we need to return the user to the terrestrial network at every opportunity. But again, not to the extent that we're banjoing backwards and forwards between the two. So I think there's lots of work to do on algorithms, on mobility management and optimization. And then more broadly, and really Starlink's recent purchase of, or SpaceX's recent purchase of MSS spectrum has brought this to the fore. What do we do about spectrum? The original concept was that the mobile operator would provide some spectrum to the satellite operator, and they would broadcast that spectrum. That's really challenging. If you look at Europe, and we've not got nice, clean national boundaries. We've got quite complex national boundaries. And, of course, you could provide interference from one country into another if you transmit in MNO spectrum. So actually, the use of MSS spectrum opens up an alternative where there's still a partnership between the NTN operator and the terrestrial network operator. However, that looks more like a traditional roaming agreement, where actually you use a standard IPX that you use to roam between mobile operators, but you roam in and out of the satellite service. Now, that calls for particular kind of orchestration and management interfaces to be defined in the standards to manage those mobility issues we talked about, and all the associated billing that comes with that as well, because it's a more abstract relationship then from a technical integration perspective. So there's lots of things to get after here, but that's just a bit of a feel for some of them, yeah. This is keeping me awake at the night, though.
Okay, shifting to cloud. How can service providers become cloud ready, offering flexible on-demand services while still managing the complexity of multiple frequency bands and orbital regimes? Francesco, you want to start with that?
Well, this is interesting. Well, I think that today when we look at satellite systems, due to the limited resources, they used to sell fixed. So you buy a fixed amount of capacity and you pay for it whether you use it or you don't. And we see more and more applications which need to be highly flexible. If I give an example, when you're doing cruises, serving cruises, you can have high demand during certain periods of the year. But when you're buying satellite assets, you're buying them for a fixed period of the year, and the boats are not in that region for 50%, 6 months. So you're paying for something that you're not using. So having the possibility to use, like you have today in the data center, scalable systems where you can buy as you need, reduce, buy by slice, and pay on the use, certainly makes a big difference. So in terms of broadcasters, we see this same event happening, taking place. When we have big events, Olympic Games or other big sports events, there's a huge demand for capacity, whether it's terrestrial or satellite or both because of resilience requests. We have to be able to adapt. We have to be able to provide the resources required for that event and then to scale down or to scale up as needed. So I think that we have a lot to learn from certain industries. And going back to the teleports, a teleport has fixed costs. They need to recover those fixed costs. And having these models where you have flexibility doesn't help. So we need to find, I would say, the exact balance between investments and revenues coming in.
Okay, great. Miguel, from a technology provider perspective?
Well, we are clearly working in a multi-domain environment, and the ground segment is approaching different challenges. We are also downloading more and more data from space, and it's clear that we need to store or manage at some point in the cloud, and also because new partners are entering into this market, like Amazon Web Services, for example. So that is really we have to digitize the ground segment, as Andrew said. I mean, we have to put the data in the cloud, and we need as an industry to develop new technology to change the architecture at some point in order to be able to do that. But not only that. I mean, it's a multi-domain, as I said, and also with the digital, with the optical ground stations. That is a new trend in the industry. For example, we as Celestia, we are really investing in modems, in optical modems, in order to be able to fill some of the gaps in terms of technology that these optical ground stations demand. And well, it's not only that; it's also space situational awareness. There are more and more things flying out there, and we need to track objects to avoid crashes between satellites and well, that is also part of the ground systems. We need to have more systems in the ground in order to track tracking radars to track the objects, and well, at the end, it is not just one thing. From a technical point of view, it is not just one thing. It's many things that we are working in parallel, and well, from a company in which we are developing technology, it is really interesting time, but also challenging. And the standardization, as Andrew said, DeFi and this compatibility between operators and suppliers is really key, because our development could be shaped by customer demands, but we all know that could be customers change minds, and we have to standardize things if we want really to be effective and efficient in the things that we can deliver.
Great. Andy, how do partnerships between operators, governments, and technology vendors need to evolve to support multi-band spectrum use, optical gateways, and integrated end-to-end services?
I mean, I think that's the really critical point at the moment, to be honest with you. We need to create a refreshed ecosystem. That ecosystem is not the satellite sector sitting on its own. It's not mobile operators sitting on their own. It is something new. And I mean, cloud is a perfect example of why that ecosystem needs to change. Because fundamentally, what is cloud? If you're not careful, it's just somebody else's computer. Yeah, and you've no idea where that computer is. So when we talk about cloud, we need to really think about, yes, third-party cloud. There's some great web scalers offering some really efficient services and capabilities, and we work with them and host services on their infrastructure. But fundamentally, when we talk about our core network, so the 4G, 5G mobile core, for example, or the IP multimedia subsystem that supports digital voice, we build this infrastructure on private cloud, not on public cloud. So we actually know exactly where those servers are. We know how information moves between those servers. We know what the environment in which those servers are deployed is. So again, we need to differentiate between the two. So I think that's a partnership story there as well, in terms of where do you partner versus where do you self-build, and then what does that self-build look like as well? Because of course the web scalers will build you a private cloud. They're doing that for governments around the world at the moment with that sovereign wrap around them. So there's a range of different models there. The engagement with academia is absolutely essential. We really are, as we've heard, you're pushing the boundaries of what is possible here. But that's going to happen. So, for us as an established sector, for countries like the UK, it's critical that we're a part of that, because if we're not, somebody else will do it. So we're going to miss out. So we absolutely have to do that. So we need to find ways of investing in that. The UK industrial strategy was a great step forward in terms of supporting space and identifying space for its strategic value. And government, of course, is at the heart of setting that policy, and spectrum policy will be absolutely critical in that regard. So again, yeah, I think Ofcom is a fairly forward-looking regulator. We've recently seen some tactical licensing of E-band for connectivity from Satcom in the UK. Clearly, that's just temporary until WRC 27, and then we'll have a wider washout of what's going to happen around the spectrum piece. So you really do need to bring industry, academia, and government together to have the right policy framework, the right technology, and the right environment in which to invest.
Great, thank you. Andrew, do you want to add to that?
Yeah, I mean, I think the partnerships area, which I mentioned before, is incredibly important for us as ground segment manufacturers. We just want to say thank you to the European Space Agency for continuing the relationship with the UK. I know Brexit is a horrible word even now, but they have been really supportive, not only to us, but a number of companies I know in this room, to continue development in new frequencies, and also in the digitization world. And also, as a result, the UK Space Agency has achieved a lot more funding and also celebrity in the fact that they're now stepping forward to support this industry in a way that they haven't done in previous years. So again, thank you to that group, and we work closely with them on their initiatives and funding support as well. But those partnerships and that funding and that vision is in a world where Satcoms, in my view, has never been under such changing pressure to evolve as quickly as it is at the moment. We're not just talking bandwidth and frequencies, we're not just talking the importance of redundancy, but the new technologies, whether they're digitization, they're optical links between constellations, but they're also the geopolitical threats that we're all facing. I don't know if you're the only American in the room, Randall, but you know, the threats that we are getting from, you know, we have to make money in this room. And while engineers, I have a love-hate relationship with engineers, that I love them, but they are not the most cost-effective group of people, and they love spending money. But we have to make sure that their work is focused and actually builds products which actually are profitable and actually provide services to teleports, which provide redundancy, provide future handling of spectrum and bandwidth. But what we are seeing in the market at the moment is huge pressure, not only from the federal government at the moment, it's closing down, Doge or Doji, whatever it is, plus our tariff threat. And I think all of those things mean we, and I'm talking here about the rest of the world, we have to work more in partnerships together. And we're seeing that, people stepping forward, and the sovereign investment as the US becomes a little bit more entrenched, has actually responded. And I'm seeing investments and projects that are emerging that would otherwise have gone to the US. So in a way, it's created opportunities for the Satcoms industry to actually step forward, and certainly GDP spend, I saw an analysis of certainly government and military GDP spend has increased by several points from UK sovereign governments, sorry, from European sovereign governments.
Thank you. We just have a few minutes left. Are there any audience questions? Renato.
Hi, Lawrence Russell, Data Center Dynamics. So we've seen an interesting uptake in the interest of building their own ground stations from Starlink and Kuiper all around Europe, all around the world, really. Do you think that that trend is going to go on? Do you think that they're really serious about a kind of verticalized system? Or do you think it's going to take to sort of roll them into a more cooperative environment? Do you even see it that way?
Maybe I can.
Go ahead, Miguel.
It is, well, and my colleagues could correct me if I'm wrong, it is difficult to work with companies like Starlink because they integrate vertically everything, and they are not so cooperative. So what I think is becoming a trend in our industry is the companies that are providing ground segment as a service, because that is a good way to be more cost effective, not just to build an infrastructure per customer, per project, per service. So I think that is the trend. There are more and more companies in the market that are providing services in the ground segment to different actors. And actually, we are seeing satellite operators that are even getting rid of their ground segment. So I think working with Kuiper, Starlink is not easy for the industry, but this new trend of companies that are building ground infrastructure to provide services, I think that is for me where we are heading and could be a good way to be more cost effective in the ground segment part.
Yeah, I think can I
Go ahead,
turn
Ian.
over as well? It's a really good question because I think, as I mentioned earlier, of course, the entire market's been skewed by two high wealth individuals. So I think you've got two unique use cases there. Certainly, if you look at Starlink, when they went to market, they didn't want to touch telco at all. You know, they wanted to deal directly with the customer, to own that relationship. And then they started to think, well, you know, as markets started to plateau a little, is there another route or another service? So if we're delivering business services, actually, does that business service not want to go to the internet, but integrate into an international carrier's network directly? Is mobile backhaul an opportunity? Yeah, in which case, again, is that a direct interconnect into the operator, as we've built? So we're actually finding that Starlink are changing their approach to the market. Clearly not necessarily around how they host gateways, but I think, again, they're ultimately going to struggle to acquire enough real estate to deploy all these gateways, and it may well be, you know, established teleports have the capability to accommodate that. And if you're going to do that, then you can also provide the power for it, you can provide connectivity for it, you can provide first, second line support on site potentially for it as well. So I think we may see some shifts, but more broadly, I think the wider sector's coming together now through a range of JVs that have been announced recently to try and look at how do they compete, or at least maintain a presence, you know, with Starlink and Kuiper in the marketplace. So we'll see more LEO constellations. Those LEO constellations will be built upon broader partnerships. I mean, we already see that with OneWeb, of course. You know, I think we'll see others, not just Rivada and Telesat Lightspeed. There's, you know, other stuff kicking off now as well. But I think those will be more collaborative efforts with the sector. So I think we'll see both, but I think there's always going to be that slightly unique case because of the very deep pockets that the two companies have.
I think on behalf of the traditional ground segment, we've already seen the consolidation between companies like Viasat and Inmarsat, and SES and Intelsat, and there will be a traditional consolidation. And this is pretty much as a reaction to what is going on in the vertically integrated market, that they've got to work together and consolidate. So the future data that I'm seeing is a reduction in the number of teleports and ground stations as we see. And this working together partnership to face not only Starlink, but also QuinFan, or whatever it's called, Thousand Sails, we need to be cost effective. And the lower cost that existing MEO and GEO can be, the more that it can actually compete and offer a service and offer a platform in which LEO is less relied on and also becomes attractive to use. So it's really good to hear about new NEO and nano GEO satellites because I think they are the future of that orbit.
I would like to add a few things. First of all, I think that Starlink has been a big shock for this industry. Positive or negative, it's a shock. It's waking us up. I think that the result is consolidation. We have to standardize as much as possible, because without that, we're going to be everybody working on his own. We need to find government helping us, evolving with rules, regulations, because the spectrum belongs to everybody, and we must make sure that we can operate in this world like everybody else with the same rights. And then, of course, then we have a problem of finance. Some people are very rich and others are not. So we have to make sure that working together, we get enough funds to make this industry continue. This is, and last but not least, at the end, it's what the customer wants. Just delivering something doesn't make the difference. The difference is delivering what the customer wants and quality of service. And yeah, I tried to buy a terminal from Starlink. I had the computer in front of me. Did I buy a terminal? The answer is no.
I think we've got time for one more question. Hello, I'm Veda Prabhu from Beambridge Technologies. Thank you for a very informative discussion. I have a question regarding the optical gateways. So, of course, it increases the data rate, and that's good. But how do you address the challenges of beam pointing accuracy and the weather considerations when you consider these optical links?
Mm-hmm. Yeah, I mean, certainly,
Andy,
I
go
can start
ahead.
things off. The beam pointing accuracy is a key point, actually, because even the weather environment itself can actually impact that beam. So that's a key area of research at the moment in BT Labs, working with colleagues at a range of different universities, including the University of Suffolk. I don't have the latest story on that, I'll be honest with you. Regarding the weather, then I really do think this is where this network of networks concept comes in. And we use underlying fibre infrastructure in the terrestrial network to connect multiple optical gateways over potentially a large geographical area. And then you constantly monitor that weather environment and you feed that back, and you're making an almost dynamic decision based upon the latency, of course, and the prediction that the algorithm can run as to which optical gateway at any instance you're sending transmission. Now, a lot of those techniques for doing that exist in a slightly different context in mobile. Look at how mobile base stations work, particularly with a centralized radio access network, the way the schedulers work, the way they take feedback, not on the optical weather conditions, of course, but on SINR from a radio perspective, and make dynamic decisions on how to route traffic. So I think there's lots of synergies, again, within 3GPP there that we could pull forward, obviously evolve and modify, but I think conceptually it's that distributed architecture and that network of networks approach that will allow us to mitigate those weather issues.
Great. We're out of time, so we'll have to continue this over coffee.